Okay, Assalamualaikum and very good morning to all of you students. Can you hear me?
Yes, sir.
Salam
Yes,
sir.
sir.
Yes sir.
Okay, good. Okay, so before we begin, I would like to share about kalam first. I have mentioned dalam kelas yang sebelum ni, I will be using kalam to put all the materials for this class in kalam. So I have made a few changes in kalam. As you can see, if you scroll down here, you will find that I did not embed the video directly in kalam because I don't want to, perhaps later some of you will have problem kalau too many videos in the kalam page. I'm not sure whether apa ni, if you watch it using, if you open kalam using your phone, maybe it will be it will require a lot of resources from the phone if I put the videos, all of that, all of the videos in kalam. So what I did was I put thumbnail of the video, and when you click on each of the thumbnail, a new page, YouTube page will be open. Okay, so I think this way is better. So if you watch using your phone also, when you click on the thumbnail, the YouTube application in your phone will be open and will go directly to the video lah. Okay, so I hope you can use kalam. Please go into kalam to get all the materials and all the videos. And for every week, I will put the video lecture where I explain all the theory of each subtopic. And also, I will also share the recording of our Google Meet session. So you can have all the videos lah, like macam ni, from week number 1, we have 2 lecture videos and 1 Google Meet recording. And from this week, we have 2 lecture videos and 1 Google Meet recording from the class on Monday. And I will later upload also the recording from today's class. Okay, I hope that is clear to all of you. And also during the class, we will discuss the answer for tutorial. So like in this case, I have uploaded the answer for tutorial 1. Kita dah bincang the jawapan pada tutorial 1 ni dalam kelas yang lepas. So I include the answer for your reference. So later you can check balik lah you punya answer whether you get the calculation correct or not. Okay, I hope this is clear to all of you. Okay, any question regarding kalam or any suggestion ke? Any of you cannot access kalam? Ada tak? Do you have any problem to access kalam to get all the materials? Ada yang tak dapat access?
No problem, sir.
Semua orang ada access, everybody has the access to all the materials. Okay, good. I hope all of you have access to the material. So I'm gonna stop sharing the kalam screen now. And let's go to what we would like to cover today, which I have already shared the video with you about erratic motion. So I hope that you have already watched the video, okay, on erratic motion. Okay, all right, so let's look at what we have learned in erratic motion. Okay, so basically, up until now, we have learned about 3 important kinematics equation. Okay, V equals to ds over dt, A equals to dv over dt, A ds equals to v dv. So in erratic motion, because we have also learned about constant acceleration, but in erratic motion, definitely the acceleration is not constant lah, because the motion of the object is changing and there are different phases of the motion. So therefore, the motion will be represented in piecewise function. This I have already explained in the previous class as well as in the video. So let's go, I think, directly to the tutorial. Okay, have you tried to answer the tutorial question?
Yes.
Yes, okay. So let me share the tutorial screen and we can discuss the answer. Okay. Can you see my screen now?
Yes, Doctor.
Okay, all right. So this will be tutorial number 2. Tak nampak? Ada yang tak nampak? Nampak Semua nampak Okay, so this will be tutorial number 2, particle kinematics, erratic motion. Okay, as we have discussed before, until now we have learned two types of motion. One is continuous motion, whereby throughout the motion, the characteristic of the motion is continuous. Dia sama saja from the beginning until the end. Sama, velocity, acceleration is the same. But for erratic motion, there are several phases of the motion. So phase 1 karakteristik dia lain, phase 2 karakteristik dia lain, phase 3 karakteristik dia lain, and so on. Okay, so let's look at the question. I have given to you only one question for this tutorial. Okay, so what is given here is the VT graph. Apa maksud VT graph? Is the velocity. Let me change the pointer. Okay, so the velocity here, V, is in meter per second. That is the unit for velocity. And this will be the y-axis of the graph. And the x-axis is the time, which is given in seconds. Okay, so dia bagi tahu dekat sini, VT graph for a train has been experimentally determined. So maksudnya they have done some experiment to get what is the velocity lawan time, velocity versus time graph for this train. Okay, from the data, construct ST graph and also AT graph. So we have been given VT graph. Now what we want to do is we would like to draw the displacement versus time graph ST and also the acceleration versus time graph AT. For the motion T from 0 until 180 seconds. So exactly the same like what is given here lah. When T equals to 0, S equals to 0. So this is a boundary condition. I mean, is the initial condition given. Apabila T is 0 over here, the displacement is also 0. So basically it is saying that the train is starting from rest lah, from a static position, and then it starts to move. Okay. All right. Before we can draw ST and AT graph, we need to know what is the function of velocity VT. Sebab VT ni is given in form of graph. We don't know what is the function of VT. After we get the function of VT, then we can do some calculation to get what is S, what is the displacement, and also what is the acceleration. Okay. Let's look at from the first phase dulu, fasa yang pertama ataupun the first stage. Stage yang pertama ni from 0 until 60 seconds. Okay, from T greater and equal to 0, less and equal to 60 seconds. So what will be the function here? How do we get the function of this graph VT? Any suggestion? How do we get this?
Using the equation y equal to mx plus c.
Thank you, Najwa. Very good. We use y equals to mx plus c. Okay, y equals to mx plus c. This is kita panggil the basic basic function untuk linear graph, linear relationship. Ini linear lah. It's a straight line. Okay, so for a straight line, it is normally represented by y equals to mx plus c. But in our case, y kita apa dekat sini? What is our y here?
6.
Y here is the velocity. No, y here is the velocity lah. Y axis is the v. Y is the velocity. And x here is the time. Okay, x is the time. So what is m and c? M here is the gradient. Ingat kita belajar dulu dekat sekolah, M is the gradient. So how do we get the gradient of this of this line? How do we get the gradient? Anyone?
Either use the formula y over x or y1 minus y2 divide x1 minus x2.
Okay, betul tapi slightly incorrect. It's y2 minus y1. Kita pick the second point first, minus the first point. So y2 dekat sini is 6. Tengok bila y dekat point 60 ni 6, y2, y1 kita is 0. So 6 minus 0 divided by x2 minus x1. x2 kita ialah 60 dekat sini. And x1 kita again ialah 0. So that is for the m. C ialah C is the intersection with the y-axis. So kita tahu garisan ni dia akan intersect with y-axis at point 0, at 0. So intersection occurs at 0. So C equals to 0. So from here we will get 6 over 60 is 1 over 10 lah. So what we will get for the first phase, V is equal to 1 over 10 t. Okay, because x ialah t. So C equals to 0, so we don't have to write C. So this will be the function of velocity for the first phase of the motion. Okay, fasa pertama pergerakan kereta api ni, train ini ialah the velocity is V equals to 1 over 10 times t. Okay, itu kita punya function yang pertama. What about the second phase? Let's move to second phase, t from 60 to 120. What will be the function of V? Diorang boleh bagi tahu saya? This is very simple. From the graph.
V equals to 6.
V equals to 6. Okay, thank you Najwa. V equals to 6. Kita nampak dia straight line sahaja dekat sini, constant pada 6. So we know that V is equal to 6 meter per second for the second phase of the motion. So this will be our second phase of the motion. Okay, let's move to the third phase, from 120 to 180. Okay, 120 to 180. So again, kita nampak dekat sini, it is another straight line, another linear relationship. So we will use again y equals to mx plus c. Okay, macam kita dah define dekat atas ni, y is v, x ialah t. So now what is left is to find what is m. Okay, m tadi kita dah bagi tahu, it's y2 minus y1 divided by x2 minus x1. Okay, so y2 dekat sini, tengok y2 is 10. y1 dekat bawah ni ialah 6 value dia. So 10 minus 6 divided by the x komponennya ialah t lah. Okay, pada yang titik yang kedua, x ialah 180. Titik yang pertama ni, x ialah 120. So 180 minus 120. So what we will get is m is 4 over 60, which is also equal to 1 over 15. Okay, 1 per 15 m. How do we get the value of c in this case? How do we get the value of C? Anyone?
Ganti nilai.
Ganti nilai. Okay, macam mana nak ganti nilai, Firzana?
Masukkan nilai V dengan X.
Betul. Okay, so to get the value of C, kita dah ada Y, kita dah ada V, kita ada M, kita ada T. So when we substitute, let's pick point yang hujung atas ni. So V pada hujung ni ialah V pada point yang kedua ialah 10. So kita put in 10 dekat sini. M 1 over 15, and x at this point is 180 plus c. So from here, we can get what is the value of c, which is -2. Okay, so once we have c equals to -2, we have m equals to 1/15. So finally, we will get the function of the third phase of the motion, which is v equals 1/15t minus 2. Okay, so this will be the third function. So kalau you boleh nampak dekat sini, ini maksud dia piecewise function tadi, ataupun ini maksud dia erratic motion, because the velocity ni is given by three equations, three different set of functions for the motion of this train. Okay, so v pada fasa yang pertama, v sama dengan 1/10t. Fasa yang kedua, it's a constant velocity, v equals to 6 meter per second. And fasa yang ketiga, v equals to 1/15t minus 2. Okay, so the train is moving in different in different characteristic of motion. So this is what we call as erratic motion. Okay, we have not answered the question yet because the question ni minta kita untuk construct the displacement time graph and also the acceleration time graph. So what we have here is the velocity time graph, VT. Kita baru dapatkan the function of velocity. Okay, so let's do this. Three different phases of the motion. Okay, so we have the first phase, second phase, third phase, and we have the function for velocity. Now, the easiest to get from the velocity is to differentiate the velocity over time. So bila kita differentiate velocity over time, dv over dt, kita akan dapat apa? What you will get when you differentiate velocity over time? Do we get displacement atau we get the acceleration?
Acceleration.
Acceleration, good. So the easiest is to calculate the acceleration first. Acceleration A is dv over dt. So when you differentiate 1/10t, what you will get is 1/10. You will get 1/10. T ni akan hilang. Okay, T akan hilang. So therefore we know that A for the first phase acceleration is 0.1 meter per second square. Okay, ini acceleration pada fasa yang pertama. So kita nampak fasa pertama acceleration dia constant pada 0.1 meter per second square. Now let's go to the second phase. V equals to 6 meter per second. So when you do dv over dt of 6, what do you get?
0.
0, because there is no variable, tak ada t dekat sini. So when you differentiate dv over dt of 6, you will get 0. So the second the acceleration for the second phase is equals to 0. A equals to 0 for second phase. Okay, sekarang kita pergi ke third phase. Third phase ni dapat apa? A equals to dv over dt of 1/15t minus 2. Apa yang kita dapat?
Jawab Fit. 0.0.
Sorry?
0.0667.
Okay, so A equals to dv over dt. So from here we will get 1/15, which is equal to 0.0667 meter per second square. So kita dah dapat 3 acceleration daripada 3 fasa yang berbeza. Okay, tak apa, kita calculate all the function first and then baru kita lukis graph. Okay, now let's go to the displacement. Yang ni a little bit tak adalah susah tapi a little bit complicated because we have to do the integration now. Okay, so we have the relationship ataupun kita punya basic kinematic equation V equals ds over dt. Sekarang kita nak S. What we want is S. So what we have to do is we bring dt to the left hand side. Okay, we bring dt to the left hand side. So kita akan ada ds and v dt. So to get S, we have to integrate. Okay, so you integrate ds, and when you integrate left hand side, we have to integrate right hand side also. And kita integrate, this is what is given in the question. Sekejap, saya go back to the question. Okay, ini yang diberi dekat sini, when t equals to 0, s equals to 0. So this initial condition is what you have to put in, here as the lower limit of the integration. Ini yang dipanggil sebagai initial condition. So we know that when you integrate dt ni, kita integrate daripada 0 hingga t. Kita integrate daripada 0 hingga t. So we need to know when t equals to 0, displacement dia berapa. So displacement ini yang diberi dalam soalan, which is given in the question. When t equals to 0, s is also equals to 0. So on the left hand side, you integrate ds from 0 to s. On right hand side, integrate from 0 to t, dt. Okay, boleh faham ke what is mean by initial condition yang saya explain ni? Ada yang tak faham tak? Ada tak yang tak faham on initial condition? Okay, so kalau ada yang tak faham nanti boleh tanya kemudian. I will proceed. Okay, from this, apa yang you dapat? On the left hand side, when you integrate nothing, ds. So apa yang kita dapat is s lah, ataupun bukan nothing ni, maksudnya you integrate 1 lah, you integrate 1 ds. So what you will get is s. And then sebab kita integrate daripada 0 to s. So basically you will have on the left hand side s tolak kosong. Sebab lower limit dia kosong, so tinggal s sahajalah. On the right hand side, it's 1/10. Pun tak ada variable t dekat sini. So what you need to do is, sorry, is this my mistake? It should be, oh saya lupa letak t dekat sini. Sorry It's 1/10t. Ini v dia kan. So sepatutnya ada t dekat sini. My mistake kan. Nanti kalau you salin this, you please put t in the function here. So 1/10t. Bila you integrate, you will get t square divided by 2 multiply with 1/10. So you akan dapat t square over 20. Okay, this is what you have from this integration. Semua dapat macam saya ke? T square over 20. Dapat okay. So kita dah dapat s sama dengan t square over 20 untuk phase yang pertama. Okay, but before we proceed to the second phase, kita nak calculate dulu at t sama dengan 60. At maximum yang the towards the end of the phase ni, fasa pertama punya time yang paling akhir sekali, which is 60 seconds. We want to know what is the value of s at this point, because this will be the initial condition untuk second phase. So at t sama dengan 60 seconds, you will substitute lah, ganti 60 in this t here. So we will get s is 180 meter. At t equals to 60 seconds, s is 180 meter. So this will be the initial condition for the next phase of the calculation. Okay, nanti bila kita dah calculate yang ni, you akan faham kenapa bila kita nak guna 180 and you will understand why we need to calculate what is the value of s for t equals to 60 seconds. Okay, let's go to the second phase. Kita akan buat perkara yang sama, v equals to ds over dt. Okay, and you will integrate ds dengan v dt. So v dekat sini is 6. Okay, but here what will be the lower limit for these two integration? Siapa tahu? For the left hand side, ds dulu, what will be the lower limit? Adakah dia lower limit dia kosong?
60.
Berapa?
60.
60 untuk
180. 180.
180, betul. Because on the left hand side ialah displacement ds. So this is why we calculate what is the value of s when t equals to 60. So on the left hand side kita punya lower limit is 180. Mana datang 180 ni? Datang daripada sini, 180 meter. Okay, so 180 until s. Ini kita punya integration left hand side. Right hand side baru 60 because this on the right hand side kita integrate with respect to time. So time kita sekarang bermula dari 60, bukan bermula dari kosong. So it will be integration from 60 to t. Okay. What do you have for the left hand side when you integrate nothing ds ni from 180 to s? Apa yang kita akan dapat?
S minus 180.
S minus 180. Okay. So kita akan dapat S, and then when we substitute S dengan 180 ni, kita akan dapat S tolak 180 untuk left hand side. For the right hand side pun sama. What we will get is 60. Okay, we will get 60 from 60 until t. So kita akan substitute dalam equation ni. So what we have will be 60. Mula-mula you ganti t dalam ni, so you get 60 minus you ganti 60 pula dalam value t ni. So you will get 6 times 60, 360. So kita akan dapat 6t tolak 360. 60 minus 360. So you can bring 180 to the right hand side. So we will get s equals to 60 minus 180. Untuk fasa yang kedua, for the second phase, this will be the function of displacement. And again, we have to repeat this process untuk dapatkan initial condition for the next phase punya calculation. So at t equals to 120, kita akan gantikan 120 ini dalam variable t di sini to get s equals to 540 meter. This will be the initial condition for the next phase. Okay. Next phase kita repeat the same process. V equals to ds over dt. Okay. And now ds, okay, kita bawa dt pergi sebelah kiri. So ds, kita punya v is taken from here, 1 over 15 t minus 2 dt. Okay. And our integration, now lower limit untuk ds sekarang berapa?
540.
540. Okay, so lower limit untuk ds ni 540 datang dari sini. Okay, 540 sehingga s. Lower limit for the time is inilah 120 from this. So 120 to t. Okay, on the left hand side sama macam tadi proses dia. So you will get s minus 540. On the right hand side equals to this part 1 over 15 t ni you akan dapat t 1 over 15 darab t square over 2. So you akan dapat t square over 30. This part is minus 2t. Okay. So kita integrate ni daripada 120 to t. So you will substitute t first. You akan dapat t square over 30 minus 2t, and then substitute pula 120 dalam ni. So minus 120 square over 30 minus 2 times 120. So you akan dapat in the end s is equal to t square over 30, yang 540 ni boleh bawa ke kanan, minus 2t plus 300. So this will be the equation for the third phase. Okay. Although we don't have the next phase to calculate, but we still calculate what is the value of t at 180 untuk kita plot graph. Okay, so we will get at t equals to 180 second, s is 1020 meter. Okay, 1020 meter. Okay, now let's plot the graph. Okay, let's go to acceleration time first. Okay, kita tengok acceleration fasa pertama 0.1 constant. Fasa kedua 0 constant. Fasa ketiga 0.0667 constant. So ini senang lah. Ini hanya straight line sahaja. Okay. So kita draw kita punya axis. The x-axis is 0, 60, 120, 180. Ini time kita lah. And then the y-axis is for the acceleration. Kita draw daripada 0 hingga 0.1. Kenapa? Sebab 0.1 kita ada untuk the first phase. Fasa pertama 0.1. And then kita buatlah dia punya senggat ni for every 0.01 meter per second square. Okay. So from 0 to 60 you have 0.1. Okay, ini from 0 to 60. 0.1. Okay. And then from 60 to 120 from our calculation tadi is 0. A equals to 0. So you draw another line at 0. 60 to 120, A is equals to 0. And from 120 to 180 tadi, A is equals to 0.0667. It's somewhere around here, 0.0667. And that will be the acceleration versus time graph for the train. Okay. So ada soalan apa-apa berkenaan AT graph? Semua clear? Jelas?
Jelas, sir.
Okay. So AT graph is pretty straightforward lah, simple. Okay, now let's move to VT graph. Okay, I will go back to this slide first. Okay. Okay, bukan VT ni, ST graph. Let me check again. Okay. This is my mistake again. Okay, I'm sorry. Please change this to S. S in meter, bukan VT. Ni ST graph. VT graph dia dah bagi dalam soalan tadi. Okay, so this is my mistake. This should be S in meter, unit dia meter. Okay, let's go back to this. So let's look at the first phase. Fasa yang pertama from 0 to 60, we have T square over 20. Okay, and kita tahu pada T equals to 60, S ialah 180 meter. So how do we draw this? We will pick the 180 meter point first when T equals to 60, and we know that this is quadratic punya function. So the graph will be the line will be a curved line, a curvy line. So we will draw a curvy line like this. Okay, this will represent the function. Okay, apa function dia? S is T square over 20. Okay, graph dia curve macam ni. Okay, graph curve macam ni. Okay, what about the second phase? Let's go back and look at the second phase. Kita ada S equals 60 minus 180. Ini apa bentuk graf ini? Adakah dia graph curve juga? Atau dia straight line graph? Anyone? S equals to 60 minus 180. Apa bentuk graph dia?
Straight.
Straight.
Correct, linear. It is a linear graph and a straight line graph lah. Okay, and then we need to know also bila S equals to 120 kita dah calculate. Bila T equals to 120, S ialah 540 meter. Okay. So kita get the point first. At 120 ni time 120 seconds, the value of displacement S is 540. So we know that it is a straight line graph, so you just connect lah this point to this point by drawing the line. Okay, so this represent S equals to 60 minus 180. Okay. Next, let's go to the last phase of the motion. S equals to T square over 30 minus 2T plus 300. Okay, ini apa jenis graf dia? What is the, macam mana bentuk graf ni? Any idea? Is it a straight line graph? Is it a curvy graph?
Curvy.
A curve. It's a curve because kat mana nak tahu? You tengok the T dia T square dekat sini. So T square is a quadratic graph again, sama macam the first phase. Okay, so when we go to, and then this is why you calculate what is the value of S at T 180. So we know S is 1020 meter. Okay, so when we want to draw the graph, we should pick the line first. I mean the point at 180. Okay, ini point dia 1020, and you know that this is a curvy graph, so you can draw a curve from 540 until 1020 lah. It's a slightly curvy graph lah, less curvy than the bottom one. Okay, so what we have here is S is T square over 30 minus 2T plus 300. Okay, and therefore we have answered the question. Ada apa-apa soalan tentang erratic motion? Ada siapa yang tak faham berkenaan erratic motion? Semua clear?
Yeah.
Okay, so basically the difference from continuous motion and erratic motion. Continuous motion kita tidak lukis graf because motion dia hanya continuous saja, sama saja daripada awal sampai akhir. But for erratic motion, to make it easier to visualize the motion of the object, kita akan lukis graf. Okay, so tu beza dia, tapi masih lagi menggunakan three basic kinematic equations. V is equal to ds over dt, A is equal to dv over dt, and A ds is equal to v dv. So tiga equation ni you have to remember lah. So up until now we have only learned these three equations saja, campur dengan equation yang constant acceleration, another three equations lah. Okay, so kalau tak ada apa-apa soalan berkenaan erratic motion, we have concluded this subtopic. Now I would like to go to the curvilinear motion. Have you watched the video on curvilinear motion? Ada yang dah tengok video on curvilinear motion? Ke belum tengok? Dah tengok ke belum?
Dah.
Dah okay. Tak apa. I will repeat just a little bit and then we will look at how do we solve some problem lah in this subtopic. Okay. Curvilinear motion ni, sebelum ini apa yang kita belajar, continuous motion, constant acceleration, erratic motion, ini semua melibatkan rectilinear motion. Yang ni kita panggil rectilinear. Curvilinear ni, ini rectilinear. Apa bentuk rectilinear ni? Rectilinear motion ni ialah motion yang bergerak dalam straight line lah. You nampak kan? Boleh nampak ke bola tu bergerak dekat screen you?
Boleh.
Nampak kan? Okay, so rectilinear dia macam ni. The motion is in straight line. In curvilinear motion sekarang ni dah jadi curve. Dia tidak lagi straight line. Kalau you boleh imagine, you nampak bola tu bergerak, dia bergerak dalam curve lah, bukan lagi straight line macam rectilinear. So this is a new subtopic lah, a new topic. So sebelum ni rectilinear, di bawah rectilinear kita dah belajar tentang continuous motion, tentang constant acceleration, tentang erratic motion. Now we will go into curvilinear motion, yang mana motionnya dalam bentuk curve. dia punya trajectory ataupun path dia dalam bentuk curve, dan di bawah curvilinear motion ini kita akan pecahkan kepada 3 subtopik lagi, iaitu first is rectangular component, which we will cover today, and then next week we will cover tangential and normal component, and finally the cylindrical component. Okay, so sekarang ni kita lihat pada rectangular component dulu. Okay, yang ni mungkin saya boleh skip. Apa application of curvilinear motion ini ialah bila kita nak measure what is the velocity, what is the acceleration of object moving in a curve lah, macam ni aeroplane or the jet here is moving in a curve lah. Okay, and also for example roller coaster ini moving in a helical shape punya motion ni, curvy juga, curvilinear motion. Okay, so let's go to straight to the rectangular component. Okay, untuk curvilinear motion for rectangular component, sepatutnya motion itu boleh berlaku dalam 3-dimensional, but I think I have mentioned earlier in this class, in this course, we are only learning about 2-dimensional motion. So z-axis dekat sini will not be included lah. We will only focus on x and y. Okay, so because of the motion dia yang curve, apabila objek tu bergerak, dia akan ada motion dalam dua-dua aksis. Kalau rectilinear tadi, let me go back to this. Okay, kalau rectilinear ni, bila dia bergerak je, motion dia hanya dalam x-axis contohnya, ataupun kalau dia bergerak atas bawah, motion dia hanya dalam y-axis. So kita punya calculation is only limited to one axis sahaja. Tapi kalau dia curvy, bila dia bergerak dalam curve, dia akan ada motion dalam x, dia akan ada motion dalam y-axis pada setiap masa. Can you imagine that? Boleh imagine tak apa beza dia? So itu perbezaan sebenarnya antara rectilinear dan curvilinear. Rectilinear motion dia hanya pada satu axis sahaja, whereby curvilinear the motion will be in both axis. Okay, akan ada motion dalam x-axis, akan ada motion dalam y-axis. Itu yang menyebabkan pergerakan dia itu dalam bentuk curve. Okay, boleh faham apa yang saya maksudkan? So dalam semua calculation kita akan ada involve kedua-dua axis lah. Yang ini the position. When we calculate the velocity, for example, dia akan ada calculation of magnitude velocity, because magnitude ni maksud dia kita calculate kedua-dua velocity, Vx, and also kita calculate Vy. To calculate the magnitude, sorry, you have to square Vx square plus Vy square and then square root. Okay, and by doing that, you will get what is the magnitude of the velocity. You understand? Ada siapa-siapa yang tak faham tak? I will not explain in detail. You can watch the video that I have uploaded for a detailed explanation. Tapi saya akan explain briefly, and then after this I will show an example of how to calculate. Ada apa-apa soalan?
ZZ tu tak payah ni kan? Dia just ignore kan?
VZ ni kita ignore because sorry. Because motion kita hanya dalam 2-dimensional yang kita akan cover dalam kelas ni.
Okay.
Okay. Okay. Same goes to the acceleration. Sorry. Same goes for the acceleration. The question normally will ask about the magnitude of acceleration, which you have to calculate AX and AY, and to calculate the magnitude, you have to do AX square plus AY square and square root. Okay. Okay. I would like to get some water. Kita break for 2 minutes boleh?
Boleh.
Okay,
Boleh,
sir.
sir. Thank you. 2 minutes break, okay? Okay, boleh kita sambung?
Yes.
Okay, let's continue. Okay, so basically rectangular component ini maksud dia ialah we will use the normal axis lah, x axis, y axis and z axis. Itu maksud dia rectangular component. Okay, nanti bila kita dah masuk the next topic, which is tangential and normal component and also cylindrical component, it's basically axis yang kita gunakan will be different. So apa maksud rectangular component di sini ialah axis tu yang kita gunakan, axis yang standard axis lah, x, y, z. Okay, ada apa-apa soalan tentang curvilinear motion rectangular component before I proceed with the tutorial?
Sorry, sir. Can I explain about the Vx dot and the x double dot?
Okay. Okay, let's go here. Alright. So dia basically dia sama macam tadi. Masih lagi kita menggunakan the basic kinematic equation tadi. To calculate Vx, kita sebab sekarang ni kita melibatkan, tadi kita ada V equals to ds over dt. Tak ada axis. I mean the axis is the same lah dalam rectilinear motion. But for curvilinear motion, as I have mentioned tadi, throughout the motion there will be motion in both axis. Akan ada motion dalam x axis, akan ada motion dalam y axis. So when we calculate Vx, we can also write it as x dot. Apa maksud x dot ni? X dot maksud dia dx over dt. Apa maksud dx over dt is the apa ni? Dia sama macam ds over dt tapi in x axis. The displacement in x axis. So x dot is dx over dt. When you calculate Vy, you can also write it as y dot. So which is dy over dt. Dot dekat sini maksud dia d over dt. So if y dot, it means dy over dt. So it is motion ataupun displacement in y axis. Okay, same goes to acceleration. Kalau tadi Vx sama dengan x dot, bila acceleration dia akan jadi ax sama dengan vx dot, because you differentiate sekali lagi the velocity, or you can also write as x double dot. Okay, so because Vx tadi, on this one, on this slide, we see that Vx is x dot. So bila dia jadi acceleration, dia akan jadi V dot kat sini. So x will be double dot. What it means is Ax is dv over dt lah. Sama macam basic kinematic equation tadi, tapi d over dt of Vx. Sebab sekarang ni based on axis. Tadi kita tak ada axis, kita tak ada two different axis moving moving simultaneously dalam setiap motion. Kita hanya ada one axis sahaja tadi for rectilinear, but for curvilinear motion you have motion in both axes. Can you understand my explanation?
Oh yes, thank you, sir.
Okay. We will look at the tutorial example nanti. Maybe you will understand better. Okay. In my videos that I have uploaded dekat Kalam, I have also shown two examples. So you can watch that video to watch the two example. Today in this class, I will share another example. Okay, for you to understand better about this topic lah. Okay, let me share the example first. Wait. Okay, while waiting, I want you to key in your attendance. I will put the Google form link in the chat box. I have pasted in the chat box, so please fill in your attendance for my record. Okay. Okay, can you see my screen now?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Okay, so let's look at the tutorial for curvilinear motion rectangular component. Okay, let's read the question first. A particle is constrained to travel along the path. Okay, so kalau you nampak particle ni yang bulat dekat yang merah ni. Okay, so dia berada dalam slot, this brown slot ni. So as this brown slot travels to the right in x-axis, this dot here is travelling along this curved path. Nampak tak? Dia berada dalam the particle ni is constrained by two external object. So dia constrained dalam curve path ni, dan juga dia constrained dalam slot yang warna brown ini. So as the brown slot move to the right, the particle will travel along this curve path. So it makes the particle move in a curvilinear motion lah, rather than rectilinear motion. Okay, if x is equal to 4t to the power of 4 meter. Okay, maksud dia x ni diberi dalam relationship to time. Dia diberi dalam relationship to time. X sama dengan 4t to the power of 4 meter. Okay, as time increase, x akan increase with respect to this function, to this relationship. Okay, determine the magnitude of particles velocity and acceleration when t is 0.5 seconds. So what we want to find is magnitude. Tadi saya dah mention dalam slide yang sebelum ni, magnitude bermaksud you have to calculate Vx, you have to calculate Vy, and then do the square root of the square of Vx square plus Vy square square root. Then you will get the magnitude. Same goes to the acceleration. You have to find Ax, you have to find Ay, and do ax square plus ay square square root, you will get the magnitude of the acceleration. Okay, alright. And dia bagi juga the function of this curve here. Okay, every curve dia akan ada function dia lah. So in this case, the function of this curve is y square equals to 4x. Okay, now let's go to the first part of the question where we want to find the magnitude of the velocity. Okay, magnitude of the velocity, I have told you earlier, is equal to vx square plus vy square square root. You will get the magnitude of the velocity. Okay, this is, or you can write this, macam saya dah answer kepada one of the question from our friend just now. Vx ni sama dengan x dot, vy sama dengan y dot. So another way to write the magnitude is you can also write as x dot square plus y dot square square root. Okay, now first let's calculate vx dulu. Okay, vx sama dengan x dot sama dengan dx over dt. Okay, vx sama dengan x dot sama dengan dx over dt. Dot dekat sini membawa maksud d over dt. So kalau dekat sini x dot, it means dx over dt. Kalau dia ialah y dot, it will be dy over dt. Okay, alright. So first kita tengok vx. Vx tadi kita dah kata vx sama dengan x dot is dx over dt. So d over dt of x, apa value of x, apa function x dalam soalan ni, dia dah diberi dekat sini. X is 4t to the power of 4. So what you will write is d over dt of 4t to the power of 4. Okay, so ini tak ada masalah lah because it is d over dt 4t to the power of 4. So what you will get here is you can bring 4 to front here, multiply with 4, 4 times 4 16, and 4 yang power ni tolak dengan 1, so you will get 16t to the power of 3. Ini ialah vx. Okay, later kita akan gantikan lah t tu sama dengan 0.5 dalam ni. Tak apa dulu yang tu. Okay, now let's look at vy. Vy sama dengan dy over dt. Okay, what is our value of y here? Okay, kita tengok dalam sini, dalam soalan diberi y square sama dengan 4x. Okay, y square sama dengan 4x. So y ialah square root of 4x. Inilah sebab kita nak jadikan dia y ni square, so kita square rootkan left hand side, kita kena square rootkan the right hand side also. So once you do this, you will get square root of 4 sama dengan 2. Square root of x, you will get x to the power of half. Square root of x sama dengan x kuasa setengah. Semua tahu tu Ada yang tak tahu tak? Saya takut you confuse mana datang x kuasa setengah ni. X kuasa setengah ni datang daripada square root of x. Okay, square root of x sama dengan x to the power of half, 1 over 2. Okay. Kalau ada yang ada soalan apa-apa, boleh terus tanya saya. Boleh interrupt dan tanya saya. Okay, now then we will do vy sama dengan d over dt of y ni kan. So what is the value of y now? What is the function of y? Kita substitute lah function of y is 2x to the power of 1 over 2. Okay. How do you differentiate this? What you will get from here? Can we differentiate d over dt of 2x to the power of half? Boleh tak kita differentiate? Can we differentiate it directly? Boleh ke tak boleh?
Tak boleh, sir.
Kenapa tak boleh, Najwa?
Sebab variable dia x tapi dia punya d tu d per dt. Something like that.
Yes. Thank you, Najwa. Betul. Kita punya differential sekarang ni d over dt. Tapi dalam function kita, variable dia ialah x. So you cannot just simply differentiate, bawa setengah datang depan, setengah ni tolak satu, tak boleh. Because dia, unless you have d over dx, baru boleh. Sekarang ni d over dt. So here comes dalam matematik dipanggil sebagai chain rule. Saya tak pasti sama ada you pernah belajar sebelum ni ataupun tak. So we have to use a method known as chain rule to solve this. Chain macam apa? Chain macam chain lah, rantai. Chain rule, rantai, rule rantai. Okay, to solve this. So how do you do this? Kita manipulate sedikit d over dt ni. Kalau kita buat macam ni, d over dx kali dx over dt. So kita boleh matikan dx and dx ni. In the end we will get d over dt juga. Betul tak? D over dx kali dx over dt. Kalau kita matikan dx dan dx, kita akan dapat d over dt juga. So dalam case ni, this is how we will solve this differential equation dengan menggunakan chain rule. Ini yang kita panggil sebagai chain rule. So when we have this, apa yang kita boleh buat ialah kita akan tulis this problem in form of this. So what you will have is d over dx 2x to the power of half multiply with dx over dt. So basically yang bawah ni sama sahaja dengan yang atas ni. Bila you dah matikan dx dan dx, dia akan jadi d over dt 2x to the power of half. Tapi sekarang we can differentiate directly because now it is d over dx 2x to the power of half. Apa yang kita dapat daripada sini? So ini you boleh differentiate directly lah. Setengah bawa ke bawah kali dengan 2, setengah yang atas ni tolak dengan 1. Macam biasa you buat differentiation. So when you will have setengah kali 2, 1 lah. And then atas ni setengah tolak 1. Jadi negatif setengah. So you have from this part x to the power of minus half. Okay. On this side, you akan dapat x dot. Nampak tak? Dx over dt ni kan saya tulis kat sini. X dot sama dengan dx over dt. Ini sama dengan apa? Sama dengan Vx. What is Vx now? Vx kita dah calculate pun dekat atas ni, which is 16t to the power of 3. So, you can then write Vy sama dengan x to the power of half multiply with 16t to the power of 3. Any question? Boleh faham tak macam mana kita buat chain rule? Dekat sini sedikit mungkin ada boleh jadi confuse sikit, tapi dia tak susah sangat pun. Any problem ataupun any question on chain rule? Semua boleh nampak macam mana kita buat chain rule?
Boleh.
Boleh Okay. Tak apa, I will upload this video later. So you can review the recording again kalau you tak faham. Okay. So sekarang kita dah ada Vx sama dengan 16t to the power of 3, Vy sama dengan ni. So now we can find the magnitude of velocity at t equals to 0.5 seconds, at t sama dengan 0.5, x is, kita dapatkan x dulu. Kita dapatkan x dulu, kenapa? Because dekat Vy ni ada value x yang kita perlu gantikan. Okay, so kita dapatkan at t equals to 0.5, x kita ialah 4 times 0.5 to the power of 4, kita dapat 0.25 meter. X is 0.25. Vx is 16 times 0.5 to the power of 3, you will get 2. 2 meter per second. That is Vx, sorry. Now Vy is x to the power of negative half. Okay, x dekat sini, that's why kita dah calculate 0.25 to the power of negative 1 over 2 multiply with Vx ni lah. You boleh put straight away 2 kat sini pun boleh. Okay, multiply with 2 dekat sini, so you will get 4. Okay, finally we can calculate the magnitude of velocity sama dengan Vx square plus Vy square square root is equal to 2 square plus 4 square square root. You will get V is 4.472 meter per second. Okay. Ada apa-apa soalan? Do you have any question? Ada soalan? So basically bezanya antara rectilinear dengan curvilinear motion tadi, rectilinear hanya melibatkan satu axis, only involve one axis sahaja. But for curvilinear motion, there will be two axes involved. Akan ada involvement of x-axis and y-axis, and that is why you have to calculate the magnitude of velocity untuk dapatkan dia punya resultant velocity. Resultant velocity itu ialah from the vector lah. Nanti saya explain sedikit tentang vector, mungkin ada yang dah lupa. When you have velocity in x and y axis, there will be a resultant vector of velocity. Itu maksud dia magnitude tadi. Okay, magnitude of velocity. Okay. And then in this case, sometime, bukan setiap masa, sometimes maybe you have to use chain rule to solve the problem. Okay, sometimes. Okay, now ada tak cara yang lebih mudah yang tak payah guna chain rule? Sometimes in some problem there is another method. Saya akan tunjukkan. Okay, let's go back to here. Sekarang kita dah dapat Vx sama dengan 16t to the power of 3, Vy sama dengan dy over dt. Kita masih nak calculate Vy, tapi sekarang ni kita nak cuba untuk calculate Vy tanpa menggunakan chain rule. Okay, so let's try to do this. And we know y square is 4x and y is square root of 4x. Okay, y is square root of 4x. Okay, since x is 4t to the power of 4, kita ada diberi dekat sini x is 4t to the power of 4. So kalau kita boleh dapatkan y punya equation ni dalam function t, kita tak perlu lagi buat chain rule. So what can we do here to avoid using chain rule is kita boleh ganti x ini dengan 4t to the power of 4. Okay, so apa yang kita buat ialah y sama dengan, tadi kita dah ada daripada sini kita dapat y sama dengan square root of 4x. Now kita tahu x sama dengan 4t to the power of 4. So kita gantikan x ni jadi 4t to the power of 4. Lepas tu kena square root kan lah. So bila kita multiply dan do the square root, we will get y is equal to 4t square. Lebih mudah. From here, kita tak perlu lagi chain rule. Kita boleh terus differentiate over t. Okay, 4t square. So you will get 2 kali 4 dekat sini 8, 2 tolak 1, 1. So you akan dapat 8t. Okay, Vy sama dengan 8t. And then kita boleh terus calculate at t sama dengan 0.5, Vx sama dengan 2, Vy sama dengan 4, and you will get the same answer. Okay, Vx square plus Vy square square root V sama dengan 4.472. So saya cuba untuk tunjukkan kedua-dua cara. Sometimes you boleh avoid menggunakan chain rule. Kalau boleh avoid, you avoid lah. Guna cara yang lebih simple. Kalau tak boleh, you terpaksa guna chain rule macam yang saya tunjukkan tadi. Do you have any question? Any question on this topic? Clear?
Clear, sir.
Clear, sir.
Okay, good. Okay, kita ada one more yang kita belum selesaikan, which is the acceleration. Okay, magnitude of acceleration. So the step is the same. Magnitude of acceleration is ax square plus ay square square root. Okay, sama macam tadi, kita boleh tulis dia sebagai v dot x square plus v dot y square square root. Ataupun kita boleh tulis sebagai x double dot square plus y double dot square square root. Okay, ini semua cara tulis sahaja, tapi kesemua ketiga-tiga ini dia represent the acceleration. Kalau kita tulis A, kita tahu dia acceleration. Kalau kita tulis V dot, kita tahu dia acceleration. Kalau kita tulis X double dot pun kita tahu dia ialah acceleration. Okay. Okay. From the previous calculation, we know Vx sama dengan 16 t to the power of 3. So untuk dapatkan Ax is equal to V dot x, which means dot ni maksud dia d over dt. Okay, d over dt of apa? Of Vx lah. So kita dah tahu Vx dekat sini 16 t to the power of 3. So kita akan buatkan d over dt 16 t to the power of 3. So ini bawa 3 ke depan, 3 kali 16, 3 tolak 2, you akan dapat 48 t square. Yang ini untuk Ax. Okay, Ax is 48 t square. Vy pula, kita guna yang cara yang mudah tadi, without using chain rule, kita dah tahu Vy sama dengan 8t. Okay. So Ay sama dengan V dot y sama dengan d over dt of 8t. So kita dapat Ay sama dengan 8. Okay, Ay sama dengan 8. So finally, at t equals to 0.5, Ax sama dengan 48 times 0.5 square, you akan dapat 12 meter per second square. Ay sama dengan 8 meter per second square. Daripada sini tak perlu untuk ganti time because there is no time in the function. And finally, the magnitude of acceleration is 12 square plus 8 square square root, you akan dapat A is 14.42 meter per second square. Okay. So that concludes the tutorial that I want to show you today. Do you have any question? Ada apa-apa soalan yang tak faham, boleh tanya. Semua jelas
Jelas sir.
Okay, very good. So don't worry, I will share the recording of today's session again with you later in Kalam. Okay, so you can watch the how I solve the problem again. And for the next class, I will share the lecture video. And before that, I will also share a few more questions regarding this topic, the curvilinear motion of rectangular component ini. Okay, so I hope you can do that before coming to the class next Monday. And we will discuss the tutorial answer first during the class on Monday. And then I will go into the next topic for curvilinear motion, which is normal and tangential component. Okay, we will use another axis pula untuk solve the problem involving curvilinear motion. Okay, so for today's lesson, we learn about rectangular component, which is using x and y axis lah, the normal axis. Okay, and the difference I have explained between rectilinear motion and curvilinear motion is that in rectilinear motion, the motion is only in y-axis. In one axis, sama ada x-axis ataupun y-axis. But for curvilinear motion, the motion will be in two axis simultaneously. Serentak, dia akan bergerak dengan serentak dalam kedua-dua axis. Pada sepanjang masa, dia akan ada x-axis motion, dia akan ada juga y-axis motion. So you have to calculate the motion, the velocity, the acceleration of both axes, and then find the magnitude. Okay, I hope my explanation is clear. Any last question from you before we end the class for today? Tak ada soalan Okay, so please make sure you fill in the attendance form. Okay, so if you don't have any more question, I would like to thank you for coming to the class today, and I will see you again on Monday, same time using Google Meet. Okay, until maybe week 4 or week 5, then only we will start do class face to face. Okay, Okay, so if there's no more question, thank you again for coming to the class. Assalamualaikum and have a good day.
Waalaikumsalam. Thank you, sir.
Waalaikumsalam. Thank you, sir.
Thank you,
Okay.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.